How's everybody doing? All right. Well, welcome to the second day of Startup Yale. My name is Stuart DeCue. I'm the Executive Director of the Yale Center for Business and the Environment, which is the joint initiative between the Yale School of Management and the Yale School of the Environment, and the host for the Sustainable Venture Prize. This is now its 15th year of the Sustainable Venture Prize and the 9th year of Startup Yale. And just to put the story into context a little bit, like a lot of things have happened internally at Yale during that time to help support, nurture, and be the kind of best scaffolding and structure for entrepreneurs inside of the university. So Sci-City, all those lovely folks from Sci-City, it has been an incredible pillar and change agent and support structure for students in and across campus. Yale Ventures, can everybody say hi to Josh Jabal? Josh, wave. Anybody else from Yale Ventures? Incredible development on the change of the structure and support for innovators and entrepreneurs all around Yale. And then externally, like this place and this state and this city is pretty amazing, and a lot of things have happened within it. So 13 years ago, the Connecticut Green Bank was founded, nation's first green bank. Yesterday, $5 billion was awarded to create a federal green bank based on that model. So this state punching way above its weight to create structures and systems that can scale up technologies. We also are sitting in the first net zero hotel in the United States. So, you know, Bruce Becker, the designer, developer of this, amazing Yale grad who helped put this thing in place. And then one of the most like for us personally and people who care about New Haven and care about this area, greatest developments is the development of Climate Haven. All the Climate Haven folks who are here, say hello. Ryan is going to be our MC, who's the CEO, but a home outside of Yale and in Connecticut and in New Haven for anybody who wants to build, tinker, create, be able to be a part of a growing movement of people who are working in climate tech. So we're really excited about where we all fit into this story and the point where you all enter it and these fantastic pictures that we have to be able to be the kind of next generation of innovators and entrepreneurs. And so this is the Sustainable Venture Prize. And first, just an acknowledgement of where we sit, the land that is here and the generations of people who've been here before us. The indigenous people and nations have stewarded this land through generations, and the lands and waterways of what is now the state of Connecticut. We honor and respect the enduring relationship that exists between these people and the nations in this land. But this acknowledgement has to be also followed by just consistent action and engagement and constant vigilance. And the kind of people that we're supporting here are a part of that relationship, and the commitments and engagement that we do through Yale is also a part of that. And so the Center for Business and the Environment has a number of partnerships and engagements that work directly on this issue. So this is incredibly important to us. We've got 4 fantastic teams. And this is a breadth across Yale, across departments, across times and kind of schools, and we're really excited to have you all pitch. I'm not going to get in the way and step on your pitches by introducing you here, but you can see them in the program, and we will give them the spot and place to be able to pitch and introduce themselves. And we have a fantastic group of judges. We've got Sarah, we've got Amir, we've got Lindsay, we've got Nate, we've got Torin, and this spans people who are working to build structures and places where more innovation and entrepreneurship can happen, people who are working in nonprofit VC funds, people who have their own VC funds, folks who are nuclear engineers who now started farms, people who are working to help create and develop innovation across Connecticut in the high school level, but also in other ways in philanthropic work. So we've got a fantastic group. They put an incredible amount of time and effort into this, and we're deeply appreciative of the time that they've done this. Please just join me before we start in thanking the judges and the teams for all the time, effort, and energy that they put into this. Now, the MC for today is Ryan Dings. He's the CEO of Climate Haven. I'm on the board of Climate Haven. It's been an absolute treat to watch him work, develop a team of fantastic, engaged people who are here to help folks who come out of pitches like this, or at the University of Connecticut, or at Fairfield, or at any other spot or place who want to find a home in New Haven. And Ryan, it's a joy to have you here, and thanks for being our host today.
Awesome. Stu, thank you so much. Before we get started, I just want to acknowledge one more very important piece of connective tissue that exists in this brilliant ecosystem, and that's Stu. All right. A big round of applause for Stu and all the work that he does. You were one of the first people I met in coming to Climate Haven. Your encyclopedic knowledge of everything that is Yale and climate is incredible. And you're such a champion for all the work that we do. So thank you, Stu, for all that you do. Really, really proud to have you on the Climate Haven board. Now, to what we're here for today, pitches. We've got 4 awesome startups that are going to be here pitching. As Stu said, my name is Ryan Dings. I am the CEO of Climate Haven, which is a community of entrepreneurs based right here in New Haven. And before we get into the pitch, I want to just say one very quick thing, which is the pitch itself should not be overlooked as an incredibly important milestone in an entrepreneur's journey. They have spent months, if not years, at work on this problem, developing this technology, and they are here to distill it for all of you in a matter of 5 minutes. And that is no easy task. So really delighted to have the 4 companies here today. They will provide their pitch. We will get questions from the judges. And then later this afternoon, we will award the prizes. So let's start with the pitches. First up, I'd like to welcome Leicester to the stage.
Hello everyone. So we are Leicester, and Leicester basically builds small-scale portable biodigesters that converts kitchen waste into cooking fuel for low-income community. The goal is to reach 10 million users in the next 10 years and create energy-efficient green cities all across the globe with the goal to help with global energy transition. Now, to share about our journey, first allow me to introduce you to Zorina. Zorina Begum is a middle-aged slum resident from Bangladesh who's responsible for cooking 3 meals a day for 5 people. She belongs to a low-income housing, and from what you can hear already, for her, cooking is a daily activity. Unfortunately, though, every time she steps into the kitchen, the lovely smile you see on this woman's face, it fades away. Why? It's because she uses biomass burning for cooking, which creates a lot of black and toxic smokes and creates a very unfriendly and unuser-friendly environment for her, causing health issues as well as making the whole cooking experience very uncomfortable for her. Because of her limited financial resources, her options for cooking fuel has also been very limited, forcing her to use biofuel. Now, because she lives in a slum and slums are located within urban communities, even the biomass that they are using, they have to avail it through black market and illegal sources. So even the biomass are not exactly cheap. So she is looking for an alternative that is not just healthier and cleaner for her, but definitely that is cheaper. Just like her, there are 1.9 billion other people in the world currently who don't have access to clean cooking fuel. It's because almost half of the world's population still uses solid fuel for cooking necessities. These biomass burning or solid fuel are considered a toxic waste because 6 to 20% of the fuel gets converted into toxic particles. This causes environmental harm as 2% of the global emission every year comes from it, and 58% of global black carbon emission is also responsible from it. It also causes more than 4 million premature deaths every year, according to WHO reports. So biomass not just is unhealthy and harmful for the health of the user, but it's also very, very, very harmful for the environment itself. Out of those 1.9 billion people, 600 million of those people can be found in the slum areas in Global South. So we want to help these people find an alternate that's cheaper. So my friends and I, we use our expertise in supply chain, energy, and product development to come up with a solution for affordable fuel scarcity and global energy transition. And that's how we built Leicester. Leicester is a small-scale portable biodigester that converts organic waste into fuel and as a byproduct gives us fertilizer. Now, the product itself or the design of the product itself is innovative because unlike our counterparts, we have improved our efficiency, we have reduced our leakage, and also solved the pressure issue. So we have ensured that our users are getting a reliable and consistent gas flow at consistent pressure, which means they are getting the flame in their stove consistently. We also have reduced our leakage by making the latest version of the model completely enclosed. And also we have safety features in the form of safety valves, which automatically lock in case of any leakage. We also have a designated person looking after the digester 24/7. So in case of any emergency, we are the first to arrive on scene, and that way we can avoid accidents. Now coming to the process. So in slum regions, because there is space constraint, we are setting up a larger size digester centrally and providing the lines to each of the kitchen. Along with the digester, we also are providing them with 4 trash cans designated for glass, paper, plastic, and kitchen waste. And we ask them to separate the waste themselves. Question is, why would the users separate the waste? Coming to that in a bit, but before that, let's talk about the conversion. So the kitchen waste is converted to fuel, which they use for cooking, and by byproduct we get the slurry, which we sell to agriculture and fish feed industry. The inorganic waste are collected and sold to recycling plants. So here we have 3 distinct revenue streams, the 4th potential revenue stream being carbon credits. Coming back to the previous question, why would they separate the waste themselves? Because we're giving them incentive by sharing our 3rd revenue stream with them. So here, the deal is if you separate the waste yourself and give us the separated waste, in return, we give you money. The monetary incentive in these low-income communities really worked out, so they are very cautious of their waste and they properly manage it. So this has caused a behavioral change which was significant for us because we are not just trying to give them energy, we're also trying to use the waste to convert it into energy. So what was once trash to them is now a treasure for them. So by doing so, we are now converting the organic waste into energy, and we are also taking care of all the inorganic waste, making sure all the waste produced within a household through this process is getting eliminated. We use a subscription-based model, so we don't have any upfront cost or installation costs. They only pay us for the gas use. We also hire people from the community for operation and maintenance, which creates job opportunity and also allows us to have a raw, unfiltered feedback and have transparency with our users. Along with that, by shifting to Leisters, people can save 33 to 84% on their monthly cooking fuel expense. So with the overall goal of clean energy transition, emission reduction, and climate change prevention, we are aligned with the Sustainable Development Goals 7, 8, and 11. We finished our pilot phase. We conducted pilot in 2 different locations, slum locations in Bangladesh, and based on that, made significant changes in our design features. With the $25,000, we want to roll out 50 digesters, which would benefit 1,000 people. This is what our fund use would look like. As you can see, majority of the fund is getting used for the making and rollout of the digester itself, and we would reach our break-even on those 50 digesters in 8 months. Now, by shifting to Leister, Zorina now smiles 24/7, even when she is in her kitchen. So the goal is to help more people like her achieve that goal. So we welcome you to join us in the journey. Thank you.
Amazing presentation.
Thank you.
Hello. All right. Amazing presentation. Thank you so much, and congratulations on all your progress. Judges, we are off with questions. Is there someone who would like to go first? Sarah.
Thank you for that presentation. Can you tell me a little bit about the team that is assembled to build this and deliver it to market?
Currently in our core team, there are 3 of us co-founders. We share the project and our license, everything equally. We come from different backgrounds. So for the product development, the person responsible is Mehdi, sorry, Mehdi Hassan. So under 3 of us, we hire labor to construct the digester itself. When we go into mass rollout, then we can get into collaboration or partnership with a company that just 3D prints the process for us. But for now, since we are only supplying 1 or 2 digesters at a time, we are using labor, hired labor, to specifically make the pieces and combine them.
Awesome. Torin, I think you're up next.
Thank you so much for the presentation. How do you think about maintaining feedstock consistency, and how much tuning is required as you place these reactors in different locations, and how much custom tuning is required to evolve to the new feedstocks?
Okay. Thank you for your question. So the first about the feedstock, we conducted a survey in 9 different slums all across Bangladesh, and we found out that most of these families produce 4 to 5 kilos of, I don't know how much that is in pounds, sorry, but 4 to 5 kilos of kitchen waste every week. I'm guessing that's like around 8 to 10 pounds. So they do produce a significant amount of waste. However, in order to make sure that we are reaching our feedstock requirements, we also will be collecting our feed from the local produce markets, which have a lot of, let me show you the photo. So the photo you see right here, this is after the end of the market, all the cuts and pieces that don't get, these are not sellable pieces. And they produce quite a big amount of it, which then gets thrown into dumps. So we also want to use that into our digesters to meet our requirement with the feed, and also make sure that that is also getting processed in our system. And for the second question of how the user has to adjust to it, so we just have to change most of the one common problem with energy transition in Global South has been that users don't want to switch to induction. They want the fire, they want the flame, they want what they're used to. With our process, we are just changing the full supply line. Yes, then we have to use a stove that is adaptive of that, but you're still getting the flame. And for these low-income housings, that is something that they prefer. So from a user perspective, you don't have to change any of your practices or behaviors. You're still working with fire. You're still taking the same time to cook. Only your fuel supply is changing.
Hi there. First of all, thank you for the presentation. Very awesome and cool company you've put together. I was wondering, if, in your own words, could you tell me, you've articulated a massive market opportunity, right? But how will this award allow you to basically scale both in the near term and work towards capturing some meaningful share of the 600 million, I think, plus opportunity you articulated?
So the 612 million, that's the market that we want to target overall the time. But initially, even in our mission, we want to reach 10 million people in the first 10 years. And even with the 25,000, we are instantly reaching 1,000 people. So that way, based on our predictions, we can reach 10 million people within that timeline. I think it's an earthquake. Groundbreaking technology.
There you go, well said.
Okay. So because this is a groundbreaking, I would not say tech, but this is a groundbreaking business model, and we are getting our, we are able to get our break even at a very quick time, which allows us to then reinvest whatever our profits are into the project. That creates more scope for us to grow. And with markets like this, for instance, when we did our pilot, we used 2 digesters which impact 20 people each. So that was 40 people right there with just the pilot. And through the word of mouth, currently we have a market available in those 2 slums who want our product, who are eagerly waiting for our product. Because it's like the next big thing. Now, oh, your neighbor has it, so you want it because it's also cheaper and it's cooler. And you get to say, oh, I'm updated. But yes, that's how we're trying to use mostly incentives with the low-income communities because this is a very financially feasible option for them. So trying to make sure we shift the people who burn biomass to using biofuel. That is our target.
Well, first of all, great job keeping composure during that earthquake, I guess. I don't know. So a great question was asked about the total market size, and you highlight this 10 million user milestone at 10 years. Based on the current estimates of it serves around 20 people. My question kind of gets down to deployment to hit that 10-year market size. So that's approximately 500,000 deployments, 125 million upfront costs. How do you think about how it scales, what costs come down? Like, how do you approach that, achieving that 10 million goal?
Well, thank you for that question. We have not done the entire financial prediction for the 10 years. We have done a user prediction for the 10 years on how we might want to reach 10 million and how each year, how many people we would want to target. But no, we have not done the financial projection for that yet. But it makes sense. I mean, if you think about it, because this is a sustainable, it is a very self-sustainable business model. And so we are hoping that once we start rolling out and get into mass production, we would be able to cover more ground. And because the digester scale itself is very flexible, we can scale it up to serve 50 people at a time, so that instead of having to make, let's say, 5 different digesters to serve 100 people, I can just make 1 or 2 large ones. Or we can scale it down to just serve 1 family of 5 and set it up in their house. So again, when it comes to designing and scale up, we are very flexible with that. We just have a standard model now for the initial slum setup that we're targeting.
Fantastic. Thank you.
Thank you.
All right, I think we got time for one final question.
Okay, I'll be quick. I would love to hear from you what you view as your biggest risks in getting to that first 1,000 or 5,000, and how you're thinking about mitigating those risks that you can see now.
Thank you for that question, because yes, there are a few risks and we have considered those. The first, of course, is because our indirect competitors in this case are the people supplying them with the illegal goods, also the illegal gas lines. So these are run by local goons or illegal parties. And once you start doing projects like that in Global South, you get a lot of threats from there. To battle that, that's why it's very important for us to have that transparency and friendship with the community and our users. So even the intention of hiring people for O&M from the community is that, and we make daily visits, updates, and we do face-to-face conversation with our users because we want them to just feel very welcome. We want them to know that the project is for them. It's for them, not for us. It helps them with their finances, helps them with their health. So getting them on our team was a crucial step, which we did when we were doing the survey, building that connection, which then gave us access to their houses and gave us access to their spaces. We also are in collaboration with one of the NGOs in Bangladesh, which is called BRAC. It's the world's largest NGO, and they are located in Bangladesh, and they do a lot of, sorry, I can't find that slide. They do a lot of sustainable development projects in rural areas. So with their support, we have also been able to monitor and control the users and our communities. So yes, that is a potential threat, but we are taking precautions to battle that with our team and with just strong community engagement and trust. Thank you.
Judges, thank you for all your questions, and congratulations to Leicester. I don't know if there's a column on the scoring sheet for groundbreaking technology, Mark. All right, onward to the next group that's coming up to present. Folks, welcome Evident Battery to the stage.
Hi everyone, good morning. We are Evident Battery. So at Evident Battery, we develop a comprehensive, non-destructive, deep diagnostic tools specifically for electric vehicle battery packs.
Battery pack is the most critical and expensive component of an EV. It accounts for 40% of its total value, dictating its performance and lifespan, with an average replacement cost of $16,000. Currently, we have a 1.5 battery pack replacement rate, which means by 2028, 2.5 million battery packs will face premature replacement, leading to $40 billion financial loss for the whole market. But what's more important is that replacing this 2.5 million battery pack means weight 350,000 tons of raw materials and emits 51 million metric tons of CO2. It's because producing one battery pack emits more CO2, carbon dioxide, than producing a regular car. EV drivers have to drive their EVs for at least 17,000 miles to achieve an EV's full sustainability advantage, which means at any time before that, if we replace a battery pack, our environment would be much better off if we just pick regular cars. So the reason behind this high volume of battery pack replacement is the insufficient inspection currently offered in the market, fail to catch early problems, and that will lead to serious problems later that leads to premature battery pack replacement. As you can see on this diagram here, there are a lot of critical systems inside a battery pack, but commercially available technology focuses solely on battery cells. But any damage to other systems could lead to catastrophic failure and battery pack replacement. Current inspection method doesn't catch that. So why would key stakeholders like Tesla, Ford accept such insufficiency? Currently, their inspection service are limited to lift up the vehicle, check bottom surface, do a BMS electrical data reading, and test drive, which are insufficient to catch all potential problems. It's because to inspect all the system we just showed, you have to perform deep diagnostics, which is a destructive process, require specific EV technicians, proper inspection environment to do that. It's a very costly, time-consuming, and dangerous process due to the high voltage battery pack nature. And all key stakeholders in this ecosystem require sufficient inspection and data to avoid financial risk and safety loss, financial loss and safety risks. Our target customers include OEMs, insurance company, dealership, and service facilities. Key use cases include pre-delivery inspections, used EV pre-purchase inspections, and post-accident assessment and repairs. So to address this issue, what we offer is a comprehensive, non-destructive, and fast inspection solution that catch all potential issues, that's preventing premature battery pack replacement and save carbon emissions and unnecessary material waste.
Yeah, I'll take care from here, talking about technology. So we combine the battery pack management system, electrical reading, the basic information, with mechanical assessment. Our technology is heavily focused on the mechanical assessment, which is developed based on three key components: the mechanical vibration analysis, robotic mobility, and machine learning algorithms. In this 2 minutes inspection process, our core technology here correlates the vibration signal signature, means the pattern, the amplitude, to the known failures on the battery pack, and use machine learning model to process those data. And on the inspection, we generate a report telling customer the key information, including the battery pack state of health, included but beyond the battery cells. Also, the estimation of the remaining useful life for the battery pack and the financial value. Our team has already built our beta product. As you can see, this is a beta product that features vibration analysis, robotic mobility, and fully automatic measurement. Based on our lab testing, our accuracy already achieved 90%. The data collected will be transferred to our cloud server, secured cloud server for further processing, which prevent our competitors or customers to infringe our technology from reverse engineering. Other advantage I want to mention here, this hardware-software technology combined during the R&D process, total cost is less than $3,000, make our per inspection cost really low. Also, it's a very fast process, as I mentioned. It's very adaptable. We can do inspection inside the shop environment for service repair shops. We can also do remote service and roadside service because everybody can carry this robot. Size of 17-inch laptop, height less than the EV ride height. Our go-to-market strategy. Short term, we focus on hardware development. We will provide this inspection equipment to our targeted customers, including the OEMs, insurance companies, dealership, and service repair shops. We will do a subscription-based model because we process data. We know exactly how many inspections they did. Based on our customer discovery, customers are willing to pay, for those business customers, are willing to pay $40 per inspection. That's how much we charge for our targeted customers. But as we accumulate data, long term, we want to be transitioning into a data analytics company, like Carfax equivalent for EVs. That moment, we'll start selling the historical data about the battery pack in formal report. What makes our technology different from our competitors' solutions is the comprehensiveness and the non-destructive manner. As you can see, our technology covers all critical systems we just mentioned in previous slides, focused on the structural and system integration issues. But our competitors' technology are narrowly focused on one or two systems within the battery pack. So financial projection and market share, we look into this in two folds. Inspection and the service. For the available market, that's $1.7 billion opportunity, represents 25% of the market share from the battery pack inspection. That is to address the premature battery pack failure, cost the market $40 billion. The second fold is the data part. That's $3.3 billion market opportunity, also represents 25% of market share to address the pain point of an insurance company with the very high claim cost. Currently, EV drivers are paying much more, 27% more than the gas car drivers. That leads to the deadly loss in this market. So our solution can address that. Carfax valuation listed there as a reference, as long-term, will become Carfax equivalent specifically for EVs. What we did in the past, we're on track to solve these problems. We incorporated, we built and tested our beta product, over 90% of accuracy, lab testing. We also signed a letter of intent with early customers. Targeting end of the year, we'll officially launch this product, expand our team, and acquire more customers. And Q2 2025 will focus on commercialization and scale up. So this is how we use this money, how sustainable venture price help us. The budget will be $10,000 used to upgrade our RD process, help us to inspect, collect data 40 times more faster. $15,000 to help us build 5 robots, deliver those robots to customers' hands. Every year we can do 60,000 inspections with that 5 robots, potentially save 900 EV battery packs, that's 900 EVs. And it reduce 18,000 metric tons of CO2 emission and 125 tons of raw material usage in unnecessary battery pack replacement. Our team has expertise spanning EV, manufacturing, and entrepreneurship. We also have support from industry academia. Our advisors are successful entrepreneurs, industry experts, and professors with decades of research experience in the battery recycling and related areas. So that being said, that's all we want to talk. Thank you.
All right, Evident Battery team, thank you guys so much. First off, we're going down to Nate on the end.
A great presentation. Thank you very much. My question has to do with the adaptability. So you mentioned it's adaptable to different environments. What about adaptability to advances or changes in battery technology? There's a lot of new climate tech companies spinning up new types of batteries. Have you tested on alternative types of cores? Yeah, I'm just curious on that.
Yeah, so our technology can definitely inspect a variety of EV brands' battery pack design, also considering the future battery pack design change, either from design side or manufacturing side. The key here is we construct a database for each type of the battery pack. The process takes about 2 weeks, costs us a couple $1,000. During the RD process, we get a brand new battery pack, collect data as baseline. We're also targeting 10 types of typical failure that leads to the premature battery pack failure. Not all the details, but the key failures mode. And then we create those failures during the RD process, collect data, feed all those data into the machine learning algorithms. At the end of the RD process, we sell that battery pack to the second market. So in that way, we don't need a customer to do upgrade for the hardware side. All the upgrade and change will be on the software side.
Why can't battery degradation and health be determined from the current charging infrastructure and feedback from those systems?
Yeah, as you can see on this page, Current technology are heavily focused on the battery cell. Battery cell is critical, but not only component inside the battery pack. We have a structural housing, we have mechanical components, electrical harness, control unit. Everything has to be properly integrated, working functional together. As a customer, you want a functional battery pack, not just battery cells. So those sensors, electrical measurement, can only tell you the information about the battery cells. When I work at Tesla, I was the lead reliability engineer there, responsible for all battery pack programs. Company started an approach called embedded sensor. See, let's add sensor to the structural part, mechanical part. But end up the sensor become part of a product, make it very expensive. Customers are not willing to pay $30,000 more just because you add a sensor to the battery pack. That's the reason why they gave up that idea. But our solution is using vibration analysis. That's a very robust, very low cost to generate a signal to understand the problem inside.
Thank you.
I appreciate, thank you, great presentation. I was particularly impressed that you identified multiple customers who care about reduced early or premature battery pack replacement. How are you going to go about getting those customers, and who do you think is your first likely adopter of that constellation of people?
Yeah, our customer group are 4 groups, as we talk about it here. So we already signed a letter of intent with the EV rental car business in the Midwest. So they own the fleet. They also care about the fleet. They care about the fleet's health condition and the financial values. So our technology can provide all those information. So short term, we're going to start with the smaller players, like service repair shops, dealerships. But 2 years from now, we are aiming to get into the OEM car manufacturer and insurance companies. The reason for that is all 4 players are in the 3 sectors in this EV business: transaction, buy, sell cars, service and maintenance, financing, providing insurance information. So we want to start with the smaller players to prove our track, and then we gradually get into the big businesses. I work at Tesla. I have a very good connection with Tesla people. I know how to get certified in their service department, and the next step will be getting into the manufacturing line. So there's lots of opportunity there. We also had an advisor from Ford, currently work at Ford, leading all high voltage battery pack development programs. So he has good connection there, understand how to get Ford service procedures. Insurance company side, we talk to many insurance companies, their venture department and their business unit. State Farm Venture, Liberty Mutual Venture, Allstate Venture, they all share the same pinpoint. After accident, I want to understand the battery pack conditions. I don't want to write off the entire vehicle, shred this useful battery pack into smaller pieces with minor or no damage on the battery pack at all. So that's the issue we can address.
Could other competitors use this kind of vibration sensing? And then when you do find a problem in the non-cell portions of the batteries, do you connect to potential solutions? So replacement parts for the other parts of the battery that might be damaged that you found out from your testing, need to be fixed.
Yeah, so the first question, we built a multiple defensive layers around our technology. First thing we did is file a patent, so other companies cannot use the same technology. The second thing we did is transfer all the data to a secured online cloud server to process the data with limited access to other customers. So that prevented the customer or competitors from reverse engineering. Even they build the same robot, they collect the same data, they cannot tell what does that mean. The third defensive layer is called early mover advantage. The earlier we get into this market, we will collect more data than all other competitors. More data means more robust model and a more higher accuracy of our prediction. Sorry, can you repeat our question?
The second part was when you do find a problem in a portion of the battery that's around the cell, do you connect to solutions, so suppliers that could offer replacement parts for the thermal barriers or the other parts that could be replaced in theory? What happens when you find a problem that needs to be fixed?
Yeah, we have a solution for that. So after we identify the problems, we're going to evaluate what's the cost to repair it to the remaining useful life and the financial value of the battery pack as is conditions. For smaller issues like ball torque loss, something you can address easily, we definitely provide guidance for the service repair people to address this issue earlier to avoid the total of the battery pack. But if it's a catastrophic failure, we can still identify what's the useful parts inside the battery pack. Let's extract those useful parts, sell it on the secondary market. The rest of the pieces will be put into the recycling facilities.
All right, I think we got time for one more question.
Thank you again for the presentation and the thoughtful work in putting together this business that you have. I have just one question around the, let's call it your pricing strategy and unit economics. This feels like, at least at the first glance, a somewhat capital-intensive business, right? So how do you, if you're deploying the technology across the nation and across the globe in the long run, ensure that you're earning a reasonable return of and on capital, but also providing meaningful value to your customers? Because, and maybe this is a dumb way to ask the question, but if a battery's got 1 year left on its life, you can detect the problems, but there may be nothing you can do about it. So I guess I'm also asking, as you've kind of built the solution set from a technological perspective, have you made sure that there's a meaningful market opportunity there that actually allows you to build a sustainable financial model around it?
Yeah, so we have a slide for the unit economics. As I mentioned earlier, during the R&D process, the hardware software combined cost is less than $3,000. So for the robot we give to the customer, when we do the large volume manufacturing, we'll expect that cost to be around $2,500. But that robot every year is capable to do inspection up to 1,200 inspections. So based on our customer discoveries, the end customer means EV drivers are willing to pay higher price, $50 to $150, depends on the size of the car. But for us, the same cost. So with that low cost, we can do the massive production of this robot, give it to different users, the business partners, so they were able to employ this technology, generate enough profit for them. That's how they get an incentive to use these technologies. We also have another version. Instead of a robot, we have a gantry system. You can think about like a 3D printer moving the head around. So that's specifically designed for the service and repair shops. Based on our conversation with Pep Boys, and they said, I don't want a robot running on my shop floor. My people always mess up. I don't want to have a collision. I don't want to have a spill on the robot. So the gantry system will work better for our businesses. But for other business like a dealership, we just talked to Toyota dealership. They said, I like a robot because I have a lot of cars in inventories parking in the parking lot. I don't want to bring every single car to the service bay and do that inspection. So we have multiple versions, the gantry system, or in the future, we build handheld devices for even lower cost.
And regarding the market opportunity, currently EV owners, they're not losing their personal money on battery pack because most of EVs are still very new. They're on warranties, they're on insurance. So what's paying out of pocket for all this battery pack replacement is our OEMs, car manufacturers, and insurance companies. So they have the most motivation to do inspection so that they can save money from battery pack replacement. And based on our customer interviews, a lot of EV battery packs are actually repairable, which means it doesn't mean that you have to, for example, manually repair a part of the component. You just simply do partial replacement, which means you don't replace the entire battery pack. Maybe it's something wrong with the harness, you just replace it, or something wrong with one module, you just replace that module. So a lot of those problems can be fixed, but it's just lack of way to identify all those potential issues.
Awesome, thank you. A big round of applause for the Evident Battery team.
Thanks.
All right, and thank you to our judges for incredibly insightful questions. I also don't know about you guys, but I've never been so excited to make it through a pitch without an earthquake happening. So that was great. We are on to the third company. Welcome, Katala.
Thank you, Ryan. Hello, everyone. My name is James Licato. I am the CEO and co-founder of Katala, and I'm very excited to present our innovative approach to water treatment to you all today. In our country, producing just 1 barrel of oil generates an average of 5 barrels of deeply contaminated and incredibly dangerous water. This produced water, as it's called by the industry, contains high levels of heavy metals, toxic organic contaminants, and can have salinities up to 4 times that of seawater. Now, to give you a sense of scale of this problem, last year, over 1 trillion gallons of this water was generated by the industry in the United States, which is roughly on the same order of magnitude as the total amount of water withdrawals from the entire Colorado River Basin. Now, where does this water go? Well, if not treated, this water goes into our oceans. And currently, offshore production platforms fail to adequately treat this water. Currently, platforms use granular activated carbon, or GAC, to trap and separate these pollutants from water. But GAC suffers from 3 key pain points. The first is that GAC simply fails to remove some contaminants, right, polluting the environment. The second is that GAC has an incredibly wasteful life cycle. Saturated GAC, after it's loaded, has to be transported to and from these platforms, hundreds of miles offshore by boat. It's then cleaned through a thermal process, which is incredibly energy intensive, and it has to be disposed in a landfill after use. In addition, these system failures can cost these platforms between hundreds of thousands and millions of dollars in regulatory violations and shutdowns. And Katala looks to function as a drop-in replacement to this system. And furthermore, these systems are incredibly unsustainable. Just to give you a sense of how unsustainable these systems are, to produce 1 pound of granular activated carbon takes 8 pounds of CO2, puts that into the atmosphere through this thermal process of combusting raw organic materials. Every time this activated carbon needs to be regenerated, that's another pound of CO2 that's released in the atmosphere. And this goes on for 3 to 5 cycles before that activated carbon ends up in a landfill or a toxic waste disposal site forever. Katala looks to destroy these pollutants in one step. We've built on years of research from my co-founders, Professor Jae-Hong Kim and PhD candidate Claire Chenard, to develop these catalytic membranes containing our catalyst, which takes a simple precursor salt added to the incoming waste stream, generates these reactive radical species that can then attack and destroy the bonds of these pollutants, reducing them down to their most simple, benign forms, harmless. And true treatment is achieved. But these membranes have broader applications than just the oil and gas industry, right? We really see this as an application in many different industries. And we believe that this industry, though, is the one that has the greatest pain point and the greatest environmental need. In conversations with dozens of offshore operators, we've learned that this market totals around $18 billion. They're paying a lot for these treatments that don't even work currently. And we've identified a $500 million beachhead in the Gulf of Mexico, of which there are around 3,000 platforms. Between 300 and 600 of them require off-platform treatment, which is something that we would provide. Compared to GAC systems used by the industry, Katala requires 1,000 times less energy. Treatment time is halved at 5% of current costs, and the elimination of that secondary waste stream, that activated carbon that goes to a landfill, slashes emissions by almost an order of magnitude. Currently, offshore service providers charge these platforms around $10 per barrel to clean with GAC. But our projected OPEX is less than 50 cents per barrel, leaving a lot of room or value for both the service provider and the startup to grow. In our go-to-market strategy, Katala sells to these service providers, right? We work with an OEM to build these membrane skids. We deliver them to these service providers, and we'll work with them, service providers like Baleen and Siemens, to pilot, integrate, and deliver these systems to offshore platforms. But the oil and gas industry is just the start, right? We believe that this technology, this platform technology, can really be applied across multiple sectors and markets, each market larger than the next. And we truly believe that this technology could be a breakthrough, specifically in the climate economy, and more specifically for water treatment. And that's where the Sustainable Venture Prize comes in to fill this critical funding gap. We've proven out this technology at the proof of concept scale, but in order to reach pre-pilot readiness, which is what our service providers need to see before they will invest in a solution like this, they need to see a fully validated prototype. And in order to build that prototype, we require capital to accomplish these 3 major goals. The demand for the technology is there in our conversations with these offshore professionals. The environmental need is prevalent and is only continuing to rise, especially as the energy transition continues. And the time to build this prototype is now. And we know that with the help of the Sustainable Venture Prize, we'll be able to do just that. since Professor Jae-Hong Kim and I started this venture a little over a year ago, we've added an incredible team of multidisciplinary talent. I've been very fortunate to work with a brilliant PhD student, Claire Chenard, in developing this technology and helping to execute our vision. And with some of these new team members that we've added in the past couple months, we really hope to build this prototype over the next quarter. Now, Katala and our mission really is to revolutionize membrane treatment for a water-scarce world. Not just the oil and gas industry, not just the food and beverage industry, semiconductor industry, but for the world. And we hope that with the Sustainable Venture Prize, you'll help us do just that. Thank you.
Great presentation, James. Thank you. A question for you. Would you break down for us the particular secret sauce? What is proprietary for you? You don't have to tell me how it's proprietary, but which is it? The membrane? Is it the salts? And for the pieces that aren't proprietary, what are your risk points in terms of acquiring those technologies?
Right. So thank you for the question. Our proprietary technology is this catalyst and this membrane process, right? So this technology is, the patent has been filed. Katala as a company holds an option to this technology. And this catalyst generates these reactive radical species. So it's an advanced oxidation process, right? And these are commonly used in other industries for the destruction of contaminants, but on a much smaller scale and not in a flow-through model. So our IP covers both the catalyst and the membrane system.
Can you talk a little bit about the amount of pressure required to use the membrane?
Yeah.
And the energy requirements behind that?
Yeah, absolutely. So these membranes are envisioned to be microfiltration membranes, right? So that those pressures can be anywhere from 1 bar to 2 bar, 3 bar, which is the equivalent of like 30, 40 psi. So they are pressurized, but the membrane and this technology can be also applied in aggregate media form. Right, so this requires just ambient pressure, which is essentially what granular activated carbon operates in the industry today. And so through this summer, in determining what sort of pressures, what sort of membrane configurations we want in this prototype, that will determine the pressures that we're using. But in the energy assessment that we completed, that hydraulic energy is already accounted for. So,
great presentation. Along the similar lines, fouling. So what is your TRL, your technical readiness level, and currently you're in the lab. Have you tested it with inputs that have all the other things that are in a sludge coming out of a well?
Yeah, so we have tested it. We have tested it with some of the other constituents. The two main important ones are the salt content. Because that does impede some of these processes, advanced oxidation processes. And the other is carbonate, right, which is prevalent in seawater, around 100 ppm. And we've tested with both. We've seen efficacy and we've seen effective removal that meets our standards enough to continue to build this prototype. So we have tested it. We've seen removal that we like.
So building off that last question, what kind of pre-treatment or post-treatment needs to happen in tandem with Katala's process in order to make the output water, safe for putting back in the ocean or other uses?
Yeah. So Katala's treatment so membrane treatment systems normally they're normally considered a polisher or a tertiary treatment step. So there really isn't any post-treatment that we would undergo. We would drop right into our service providers' existing treatment trains. Normally that's with skimmers, which take oils that are like dispersed oils, not dissolved oils, and takes those off the top of the water. But dissolved oils are really what we're targeting. So pre-treatment would include like DAF or air flotation, right, to remove some of those oils that aren't dissolved. And that's about it. And that's the reason why we're targeting offshore, right? Because onshore, you have to worry about salinity, right? That's a big issue. But offshore, salinity is not an issue that we have to worry about. Regulations really only dictate that you have to worry about oil. And that's where our technology is ideally suited to remove just these organics, because that's what it does. It's an organic destruction mechanism.
So with the amount of money involved in a technology like this and the markets that this is involved in, and the liability that the problem you're trying to address presents. Can you talk to us a little bit about the competitive landscape? What are others doing? Certainly, Katala is one of at least a few players.
Yeah, so currently the only treatments that they're using to Baleen and Siemens, and there's a few others, right? These are service providers that use integrated solutions, so they have subsidiaries, but they're really only using granular activated carbon on these offshore rigs, right? They currently don't have a fix for this problem of what to do with this waste or how to take it back to shore. Onshore, there are some competitors, right, like Aris Technologies are based out of Texas that they target onshore produced water, but offshore there really isn't any competitor that has a technology like ours that we've seen that is looking at destroying these pollutants. And also, follow up on your previous question, we're at TRL 3 is our level.
So tell me a little bit about how this becomes a big business. So I'm seeing, 50 cents per, I don't know if that was a gallon or barrel for treatment. That's wonderful. But in terms of your own revenues and growing them as a business, do you see, licensing this? How do you get to, say, 100 million in revenue?
Yeah, so right now that 50 cents per barrel, that is at the upper end of our OPEX. That is the highest that we would ever want to go. And currently, for treatment specifically for WSOs, with water-soluble organics, onshore they'll pay between $1 and $1.50 per barrel. So that's already, we're at profit margins over 100%. And then on a per barrel basis. On some of these platforms, one platform might produce 10,000 barrels of water a day, right? And so they do charge on a per day basis leasing model. So in that sense, it's really just about getting to these service providers, each of which controls around 20% of market share. These are big providers, but they all provide a very niche service, which is directly servicing these offshore platforms for off-platform treatment, right, of this water, because they're not meeting regulatory guidelines and what have you. So we would take a chunk of that $10 that they're currently charging. They, of course, would take a percentage, but at OPEX that low, in conversation with them, they're very excited for a technology like this to be potentially delivered. So scaling would be relatively easy. Again, if you scale to, if every platform is around 10,000 barrels a day, and there's 300 platforms that you're targeting, and let's say you capture even 50 or 100 of those, that is a lot of money per year. And in other markets as well, like Brazil, North Sea, it can grow very quickly. And that's the feedback that we've received as well from them.
Amazing, judges, thank you. All right, folks, now a quick reminder. You should see one of these cards. Near or on your seat, there is an audience choice. So make sure you make a vote and you return these so that you can participate in the audience choice prize as well. All right, from the oceans to the farmland, let's welcome the next team, Prospect Growth. Welcome to the stage.
Great. So hi, everybody. I'm Wyatt Arnold. I'm here today with Andreas Backhaus. We're the founders here at Prospect Growth. And what we're doing is we're nano-engineering next-generation fertilizers with the hope that we can increase agricultural yields while ultimately minimizing harm on the environment. And so I want to start out today with the fact that sort of the vast majority of all applied fertilizer ends up being wasted and lost to the environment. In a sense, this can be as low as 50% for nitrogen-based fertilizers, up to something like 90% for phosphorus fertilizers, and this can be even higher for secondary and micronutrient fertilizers. And the big issue with this is it leads to some global damage. It causes gigaton scale emissions that are more than twice as high as the global aviation sector. And it causes sort of irreparable damage to a lot of terrestrial and aquatic ecosystems on a global scale. But despite sort of these unfortunate realities, fertilizer itself is fundamentally essential. Without fertilizer, half the people in this room today could not be here because fertilizer supports the caloric needs for half of the world's population. It's also used in the majority of farming worldwide. But despite this importance, it's really a century-old technology. The last really major innovation in fertilizer came nearly 100 years ago with the Haber-Bosch process. And so we think that in order to feed the world without sacrificing the environment, what we need are next-generation fertilizers that are more efficient, but they also have to be something that farmers themselves want to use. And so we're trying to answer this call by producing nanoparticle-based fertilizers. And what these nanoparticle-based fertilizers do is they supply nutrients to plants in a new, highly bioavailable format that's much more efficient than conventional fertilizers. And if you don't want to take our word for it, there is over a decade of peer-reviewed literature supporting these claims. And so we really think this technology has the potential to be transformational, and that's because it has a number of key benefits. These includes facts like you have extremely efficient uptake of these fertilizers through a number of application pathways. This could be a foliar spray, this could be a seed coat, a soil application. They can also increase crop yields by up to 20 to 30%, which is a dramatic increase, and this is important for motivating farmer adoption of this technology. You can also see huge dosage reductions on the order of 50 to 90%, which gets back to this idea of limiting the waste and runoff and impact on the planet. And just a little bit more context about what these nanofertilizers are, is they're fertilizers made of nutrient particles that are really small, less than 100 nanometers in size. This is on the order of a DNA molecule, and you can make any nutrient you want into a nanoparticle or a nanofertilizer. This uniquely small size enables direct uptake of these materials through plant cells, and they can also be engineered to have unique functionality. For example, you can make them crop-specific, or you can even engineer them to be rain-fast in areas with high precipitation. And so we really think that this technology is sort of a comprehensive solution to crop nutrition. And we know that there are other technologies on the horizon that are trying to improve the efficiency of nutrient use. This includes things like precision agriculture, GMO crops, microbials, which improve the soil microbiome. But oftentimes these technologies sort of excel in one area but have key limitations. Take, for example, microbial products. You can see meaningful dosage reductions from them, but they usually only address one nutrient, and they're oftentimes very susceptible to environmental conditions. And so we really think our solution provides a holistic answer. It can address all 12 or 13 different nutrients that a crop needs. You can see meaningful dosage reductions to help the environment. There are yield improvements to motivate farmer adoption. You have sort of gigaton scale greenhouse gas offsets, and we think that it's really reliable. It's not environment dependent. But that's all to say that we still hope these other technologies succeed. We want a greener agricultural future in general. But really, our idea is that without the right foundation of crop growth, which is crop nutrition, it doesn't matter if you have a great GMO. It doesn't matter if you have a great soil microbiome. If your crop is deficient in a key nutrient, it's just not going to grow optimally. And so we sometimes use the analogy like an elite athlete can't excel without the proper food. It doesn't matter if you have the LeBron James of some corn GMO or hybrid. If all you're doing is you're feeding him McDonald's, he's not going to play very well.
Yeah, and you might be wondering why are nanofertilizers on the market by right now? And the problem so far is that the manufacturing has been way too complicated, using toxic reagents. The costs were way too high, small scale, and no customization for specific crops, soil conditions, and climatic scenarios. And we've developed and patented a process that uses EPA-grade food-safe reagents to make these nanofertilizers in a standardized batch reactor system. We have demonstrated scale-up of a factor of more than 1,000, and we have precise control over the size, the functionalization of these nanofertilizers. We are the right team to do this right now. So Wyatt has a farming background, a timber farming background, a PhD in plant and soil science. He just defended his PhD. He's going full-time to Prospect Growth right now. I'm a PhD on the nanomaterials manufacturing side. I'm graduating in July and then joining Prospect full-time. We have a great team. We have an former agricultural supply chain sales expert who is advising us then when we talk for farmers that we don't sound like we have no clue what we are doing. Furthermore, we have an expert in scaling sustainable startups, and we have a scientific advisor who is a world-renowned expert, Professor Julie Zimmerman, on the sustainable manufacturing, design, and application of nanomaterials. When we were on the field last year in summer and in fall, we realized that farmers really want this. We talked with farms, farmer associations, we talked with state and federal agencies, and the largest operating cost for farms is fertilizers, and they're really willing to try out new fertilizers to either decrease their overall inputs or drive up their yields. All the ingredients also comply with USDA organic agriculture. How we are going to tackle this market is in 3 steps. We will first focus on the most limiting nutrients, which is most of the time micronutrients such as iron, manganese, and zinc. before we scale to macronutrients, which is phosphorus, nitrogen, and potassium, the things that you've probably heard of in terms of fertilizer. The micronutrient market alone is a $1 billion fertilizer market in the US, and we think we can capture 0.5% of that market share in the coming years before we then scale our operations in terms of volume to tackle macronutrients. We filed a provisional patent. We are going into national I-Corps this month, where we will go on formalizing sales offtake agreements with farmers. And this summer, we are going heavy on field testing. And this brings us directly to the SVP ask. So every dollar we get from the SVP price will go into field tests with different stakeholder organizations, because no matter how scientifically proven these fertilizers are, farmers will only go into offtake agreements if we demonstrate the efficacy of these fertilizers ourselves, but if possible, outsource as much with reputable organizations such as the Connecticut Agricultural Experience Station and the Hawaii Agricultural Research Center.
And so just kind of bring us back out to sort of the macro scale picture, we're trying to lead sort of a paradigm shift in what fertilizer is. And so we want to use this technology to essentially make fertilizers more efficient, greener, have lower impacts. And so we sort of envision a future where we're making the application of fertilizers as precise as possible to limit off-target and adverse impacts on the environment, with the hope that this helps farmers sort of continue to be the important stewards of the land that they are. And with that, I want to thank everybody for their time, and we're happy to take any questions.
All right, guys. Thank you so much to the judges for questions.
Thank you for that presentation. Kind of two questions. One, talk to me about cost. So, what would be the net cost to a farmer? They're using less of this version of fertilizer than they otherwise would use for conventional fertilizers, but does it cost more to produce and more to buy? Well, let's start there.
Yeah. Tech team, can you click on the business model slide, if possible? That's a great question, because farmers are very good economists. They really care about costs. They really operate on very tight margins. And we modeled our micronutrient employment, where we price it at $15 per acre. That's 7 to 10% of the overall fertilizer cost a farm operation has per acre. And pricing that, we are cost competitive in our manufacturing. So we have our cost for manufacturing this is about $7. And looking at the short-term project where we would manufacture this, supplying thousands of farms in the US, so there are way more farms than we would supply here, and having an operation that's with a footprint, if you would picture that, it's about a third of East Rock Brewery in size. So it's like an industrial operation, but not a gigantic industrial operation. We could serve these farms and generate a net project value of about $3 million over the next 5 years, only looking at micronutrient fertilizers.
Okay, thank you. And then the next question was just about how you anticipate these nanofertilizers would perform in the field. So basically, they're more available for the plants to uptake. Are they also more available for fungi or microbes in the soil to uptake? And then again, because the particle size is different, do you expect them to dissolve in rainwater and percolate out of the soil faster, or sort of any other downsides to having a smaller particle?
Yeah, that's a great question. And so the way we sort of envision applying these, and the way that they're commonly sort of studied in the literature, is via a foliar application is the most common. And the idea is there that you're applying the particles, the fertilizers directly to the plant, and you try and get really high uptake directly on the plant. And so you're trying to get 90+% nutrient use efficiency of the particles going directly into the plant, that being metabolized by the plant, and then there's sort of no excretion of additional nutrients. And so we're essentially trying to remove the addition of fertilizer to the soil. That's not always practical for different localities, but the idea is if we go through something like a foliar path, it can be the most efficient pathway. You bring up sort of an interesting question about the microbiome. Broadly, you don't want to mess with the microbiome too much, and so reducing, let's say, lots of nitrogen input is great for sort of maybe having a healthier soil microbiome. But the microbiome still needs sort of unique nutrient inputs. For example, cobalt is a big enzymatic cofactor in nitrogen fixation. And so we've had thoughts in the future, and there's thoughts about these technologies that you can maybe modify your nanofertilizer composition to be a little bit overspray or have additional benefits for the soil microbiome if that's needed. Because we're sort of leading this change in thought about, you're not putting fertilizer into the soil and the plants are just taking up a little bit. You're trying to sort of just like minimize the impact on the environment, and the plants are almost sort of this island of treatment. Thank you.
Great presentation. Thank you. Do you think you can build in layered or timing functions to release nutrients at different times?
Yes, that's a great question. That is one of the parts of our patent of making these nanofertilizers. We're able to make like layered nanofertilizers, so one nutrient at the core, other nutrients at the shell, and have a bioavailable coating that also has some tailorability for different cuticula of the plant. So we have some timed release aspect into the design of our manufacturing process.
I could imagine that would result in less passes on a farm. You'd have to, treat less often.
So thank you for bringing this up. So Wyatt also talked about rain fastness. So we can fertilize at time points where you conventionally couldn't put on top dress on your crops. And that enables you to boost your crop growth at different time points where you couldn't do that previously in the growth cycle throughout the year.
And maybe I'll just add on that there's some like really cool options to like expand that further. Of like you could have time release, like you say, and then our coating, which is this bioavailable or bio-derived coating, is like stable from a functional standpoint, but not so stable that it's an environmental issue. And so you could time it so there's good time release to avoid precipitation, but then the particle degrades before there's risk of runoff, getting into the oceans or something.
Really appreciate the presentation as a farmer myself. So anytime we work with startups on our farm that are going up against big competing interests, right? We always ask them, okay, you're pissing off big blank whatever. Who is the champion that's in your corner and why?
Yeah, that's a great question. And that's why we staged our marketing approach going with micronutrients first. So if you would start with macronutrients, you would directly compete against the mosaics of this world in terms of fertilizer provision with deep supply chains, deep contacts to the farms, to the granaries, to the agronomy sales stations. But if you go with micronutrients first, these are generally the competitive landscape. There are also much smaller companies, and you can ship these small amounts. The logistics are much easier of getting them to the farm. So with that, you can build farmer connections first before you have to tackle these really deep, larger competitors. Yeah.
So in that spirit, and I appreciate that, but there's going to be a pushback from these large interests, which you're trying to gain market share from. So how do you expect to, because historically, like the farmers are the the small fish in the pond with the smallest voice, even though they're the ones actually producing the food. So is it precision agriculture? Is it insurance? Is it producing data? Like there's different types of ag tech that they have one of these big players with the money sitting in the corner. So just curious.
Yeah. I think we've had the most traction, like the one that's, best in our side of the ring has been sort of like large grower organizations so far. Like we've talked with large sort of farming consortia back in the Midwest. And I think that they are interested in advocating for this technology because it has a way to reduce nutrient inputs without, reducing your yields. And that can be big for them in reducing the carbon intensity of their crops in ways that they haven't found other fertilizers capable of. And so I think they would be willing to, and they have so far, we have some things planned, but sort of step up for us and maybe advocate for us in these discussions. There's also a really great nonprofit out in Indiana, where I'm originally from, that sort of interacts with these big players like Corteva, and I think would help us sort of, interface with them nicely. And I think, further to your point, we think for these micronutrients, we can kind of go direct to farmers because it's sort of a smaller, more niche product. But in agriculture, I mean, like you're getting at, the farmer, like this network is so occluded, like there's like personal family relationships to sales reps who are then like contracted to these big nebulous distributors. And I think for macronutrients, we'd have to like play along with those distributors. For like CHS or something, we'd have to partner with them for the actual distribution of this product, and then we'd think about the royalty and the cost sharing after that.
All right, we got time for one final question. Lindsay, you want to bring us home?
Sure. I had a quick question about your inputs. You mentioned everything is sort of matched with organic standards. I'm sure that stuff isn't in incredible supply. How are you managing your own supply chain?
Yeah, that's a great question. So especially for the inputs, that's one of the unique parts of this process. So the coating and the reagent that basically makes this nanoparticles is actually a waste product of soybean and corn farming. So we can recycle basically a product. We have groups we talk with who have a big interest in actually finding off-streams for this, what's considered waste, that we can use as a reagent for our process. The other input are the nutrients, so the metals, those are metal salts. They're very common, iron chloride, manganese chloride, they're very common inputs you can source in bulk. Yeah, thank you for the question.
Awesome. Prospect growth, everybody. All right, we've now heard from our 4 finalists today. We got 3 things to cover really quickly, but first, I just want to say thank you to the judges for your incredible questions. A big round of applause for our judges today. Really appreciate each of you being here and the time you gave to the competition.